All right, welcome back to the second video in our chemical reactions unit. In this video, I want to talk about balancing equations. Before we just set out to balance, I'm going to assume that many of you did some balancing in middle school, so this won't be completely new, I hope. Even if it is, it's okay. We'll get through it. It's not something we usually struggle with every year. But over the years, I've developed a few rules of thumb for balancing equations. And what I mean are these are just things that make it a little faster. If you can, what I've discovered is if you see certain things that are broken, fix these in this order, and you'll spend less time doing it. That doesn't mean if you don't follow my rules here that you can't balance it. That's not true at all. It just sometimes may take you longer. And that comes with practice. With most things, you don't just wake up and become an expert. You need to practice. When we balance equations in the first bullet here, let me just point this out. We're only adding coefficients. We will never change a subscript when we balance because doing that changes the identity of the compound. So you will never add or change a subscript when you balance. This is coefficient only. The second bullet is also very important. A lot of people, when they try to balance equations and when they address any kind of problem in life, they try to see the whole picture. And you don't feel comfortable making changes until you see sort of the finish line. That will often happen in balancing equations, but there will be times where you don't see the final answer. You need to have the ability to work on a little faith. If you see something that needs fixing, fix it. A lot of students struggle with where do I start when I balance equations? There is no correct answer to that. So if you're ever unsure, if you see an element that needs to be balanced, balance it. And just let that step take you to the next step, which takes you to the next step. You may make some terrible decisions, but if you just balance one element at a time, eventually you will get to the right answer. Now, the next few bullets are just some tips that I've learned with experience. One thing that I noticed was that when I have an odd, even, unbalance, so for example, if I have one oxygen on the left and two oxygens on the right, I have learned over time that if I multiply the odd numbered thing by 2 to make it even, it usually makes it very easy to balance. That goes with 2-3 imbalances, 2-5 imbalance. Whenever you have the odd number, put a 2 in front of that, and that will usually get you going to balancing it. It doesn't mean that's the only thing you do, but that's a good start. Another thing that I've learned is to save elements that are by themselves, such as the element copper if it's by itself, or the diatomics, which would also include elements by themselves, oxygen, chlorine, Brinkelhoff, all those guys. Leave those last because you can always fix a lone element at the very end by putting one coefficient, and that would also include fractions. I don't have that on the bullet list here, but let me just go ahead and say it is perfectly reasonable to use fractions to balance. Now we will go back and multiply everything by a factor later to get rid of the fraction. But for example, take O2 here. If I put 3 halves in front of O2, that gives me 3 oxygen atoms, and that's very reasonable. That's fine to do that. If I wouldn't put a 3 halves in front of calcium because I can't have a half of a calcium atom. I can have half of a pair, so doing it in front of a diatomic makes sense. I'm going to show you some examples where I will use the fraction, and I think that'll make more sense later. But sum it up, save elements and diatomics to the very end, and use a fraction when appropriate. The next bullet, keep polyatomic ions together whenever possible. Take a look at your reactants and take a look at your products. If you see SO4 on the left and you see SO4 grouped together on the right, leave it there and just balance your grouping instead of breaking it up and balancing your S's separate and your O's separate. That usually sends you down a road that calls for more steps. So leave polyatomic ions alone. And the final bullet here is for combustion reactions. And this really won't make a lot of sense until we get to the examples when I can show you this in action. So you may want to print this or take your copy from class and refer back to these little, this little last bullet in the 3 sub-markings here as I balance combustion reactions coming up. But combustion reactions are very simple. You always have a carbon fuel, you react it with oxygen, and you make CO2 and water. So what I've learned is that the carbon subscript will always become your coefficient for CO2. The number of hydrogens, that subscript, will always be divided by 2 to become the coefficient for the waters. And then really our job then is to add up the oxygens, and that's saving the oxygen for last because it's a lone element. Again, I know that makes no sense until I give you some examples. So let's not dwell on that. Let's get to the examples. All right, here we are with our examples. In the first reaction here, we have ammonia plus oxygen. So I see this, O2 is by itself. Let's leave it. Let's wait and do that one last. So let's focus on N and H. I have one N and then one N here, so those are balanced. But then I see hydrogen, I have a 3 and I have a 2. So that's an example of where I have an odd, even, unbalanced. I've learned that if we take the odd, put a 2 in front of it, that makes it now even, and that helps me balance this thing out, 2 and 3. I don't want to address the oxygens yet because we'll save those for last. So let's look at what happened to the N's. By putting a 2 in front of ammonia, I have 2 N's, and now on the right for NO, there's only 1 N. So I need to fix that with a 2. In a way, that's also an odd, even, imbalance with the 2 and the 1. So now we fixed everything except oxygen. So let's count up the oxygens on the product side. I have 2 times 1, so 2, plus 3 times 1 is 3. So that's 5 halves. So going back now to the oxygen, I need 5 out of that. What do I multiply times 2 to give me 5? And that answer is 5 halves. Whatever you need over the subscript will give you the number of oxygens you need. Okay, so now we have a balanced equation. Now we don't really want to leave the fractional coefficient, so what we're going to do is we'll multiply the entire reaction by 2, and that'll give me the coefficients of 4, 5, 4, and 6. And that would be the final answer for that one, 4, 5, 4, 6. Of course, you could erase it and put it in its normal place as well. Okay, let's skip number 2 for now, and then let's look at number 3. I'm skipping number 2 because it's one of those combustion reactions that I told you about. We'll come back at the end and do number 2 and number 7, sort of at the end. In number 3, as I start counting, I see calcium 1 on the left, 1 on the right, so calcium's good. Silicon is not balanced, but I want to wait and do it last because silicon's by itself. Antimony is currently balanced, and then we have chlorine, 3 and 2. So here we have another odd, even, imbalance. So I'm going to address that by making the odd number even, multiplying by 2. And that means I need to multiply over here by 3. So I fixed my chlorines. In doing that, I changed calcium. So now I have 3 calciums. I want to fix that right away with a 3 on the left. So now my chlorines are fixed, my calciums are fixed, but in the process of fixing calcium, I adjusted silicon. So now I have 6 silicons, and because silicon's by itself, that's a very easy fix. The last thing to fix are the antimonies. I have 2 antimonies, and because I'm waiting to last, that's an easy fix as well. Let's actually skip number 4 as well. It's a little bit harder. Let's do 5 and 6. Those are about the easiest ones on this page. Probably should have done those first in retrospect. All right, so in number 5, I have 4 phosphorus and 2 phosphorus. And then I have 5 oxygens and 2 oxygens. It doesn't really matter where you start here because both of these cases are where you have elements by themselves. I want to go ahead and fix the phosphorus with a 2. And that gives me 10 oxygens, which I can fix really quickly with a 5. So 1, 5, 2 would be my answer for number 5. Number 6 is almost as easy. My irons are not balanced right now. But here's an example of saving yourself a step. I could fix the iron right now, but that's going to add a completely extra step to this. If you follow my rules of thumb and address the odd, even imbalance first with the oxygens, you can get a 2 and a 3, then you can put a 4 in front of the iron. If I had started with iron and I had put a 2, I would have to end up going back and changing that 2 to a 4, which is not wrong. It's just an extra step that you wouldn't have to do normally. Okay, number 4. Let's look at this thing. It's ugly looking. Now, number 4 is sort of using that rule of thumb about the polyatomic ions. And you can kind of see here, I have a grouping of elements that's the same on both sides of the yield sign. So what I'm going to do is I'm going to try to balance that grouping. I have 3 of them on the right, so let's put a 3 in front of that to balance that grouping. Now doing that upsets my hydrogens. I have now 3 hydrogens here and only 2 over here. So what I can do is, there's a couple things I can do here. I can go back and now do the odd, even, and balance, or I can just fix hydrogen since it's by itself with a 3 halves. And I want to do that here to get you more comfortable with the fraction idea. So now my CH3O is fixed, my hydrogen by itself is fixed, and we just need to look at the aluminum. In this case, aluminum is perfectly fine. So everything is balanced, but I want to multiply the entire thing by 2 to get rid of that fraction, so that my final coefficients will be 2 for the aluminum, 6 for the, what is going to be methanol, I believe, and then 1, nope, sorry, that's a 2, and then a 3. So 2, 6, 2, 3. All right, let's go back now to number 2 and number 7. Let's do these combustion reactions. Refer back to those rules I gave you about combustion. You know what? I think a better one to start with instead of number 2 would be number 7. It's more straightforward. I'll go back and do number 2 afterwards. So the first thing I said about combustion reactions, we have a carbon fuel. We're going to react it with oxygen, and our products are always the same when it's a carbon fuel. So my rules were take the subscript for the carbon and make that your coefficient for CO2. And the reason is all the carbon is into the CO2. That's the only location, that's the only endpoint for carbon. Then I said take the hydrogen, and since it's H2 over here, I want to put half of the hydrogen in front of water. So half of 22 is 11. And let that be my coefficient. So C is balanced, H is balanced. Let's count up our oxygens on the right. I have 12 times 2 plus 11. So that's 35 oxygens. So I need 35 oxygens on my reactant side. Now don't forget you have 11 already, and we don't want to mess with those. Because if I mess with those, I'm going to change the 12 and the 22, and I don't want to do that. So I need 35. I've got 11, so that means I need 24 out of this. 24 from there, which means I just put a 12 in front. So that's about as much work as you'll ever have to do to balance a combustion reaction. But that was pretty straightforward with the rules. So let's go back up to number 2. Let's count our carbons. We have 1, 2 carbons over here. So let's put a 2 in front of CO2. Now let's count our hydrogens. I've got 3 plus 2 is 5, plus another is 6. So let's put half of that number in front of water. Now let's count up the oxygens. 2 times 2 is 4, plus 3 is 7. So I need this to be 7 over here, but I've already got 1. So I really only need this to be 6. So let's put a 3 in front of that to give me a 6. And now that equation is perfectly balanced. Now number 8 is a great practice. This is one of the hardest equations to balance that you're ever going to see. We're going to do some other ones in class, but I want you to hit pause and I want you to think about number 8. I want you to spend some time balancing it. It's going to take you 10 to 15 minutes, around 20 minutes if you're diligent. Don't give up. But hit pause and give it a good effort. When you can start balancing these really hard ones, and it's about as hard as any you'll ever see, then you are ready to move on. So hit pause now. Did you get it? Well, here's kind of the way I thought through this one. The first thing I kind of noticed here was I counted the oxygens. I saw oxygen was split up and there's oxygen in all 3 of my products. So I look, I have 3 oxygens, and then counting them up right now, I have 8. So real quickly, I knew that my least common multiple of those 2 numbers would be 24. So I kind of took a real sneak peek ahead and know that this is eventually going to be 24 oxygens there. So I started with an 8. Now, the next thing I did before I jumped into it and started balancing N's and O's is I looked over here and I see that I have an N by itself. That's an odd, even, imbalance. Odd numbers are typically bad, so I took a guess and said, let's make that a 2. Now, as we think about this, I see I have 8 H's and 2, so I put a 4 here. And now it really is, what do I do about the N's? I have 8 N's on the left, I have 2 on the right. So, oh, and also I have 2 more, so that's actually 4. So I don't really want to play with both of them. I want to take a stab here. Right now I have 2 times 3, 6, 4, 2 oxygens. That's only 12. I'm about halfway there. The quickest way to get to the 24 is to manipulate the copper 2 nitrate. So if I multiply that times a 3, that will change that to a 18. So I have 18 4 and 2, which gives me the 24. And now I fixed the 3 from the copper, and we've balanced one of the hardest equations that you'll ever see to balance. There is no magic wand here to wave and let you be able to do number 8. We're going to try some more difficult ones like this for a warm-up in class. When you can do the hard ones, the easy ones are insultingly easy. And that's what you're going to focus on next. You got 50 to practice on your own. We'll do the hard ones together in class, but if you don't understand the basic premise, come see me and we'll get it sorted out.